So our learning target is like terms and distributive property. We're going to apply those two things. And I don't normally take a volunteer. I normally like to call on you randomly, but I'm asking you to recall something from quite a way back. So I'm going to just go ahead and take a volunteer for right now. I need somebody to tell me, what the heck is a like term?
Like 4 ends and 10 ends, they have like terms, so you can just like distribute them. If they don't have like terms, you can't do nothing with them.
Okay, so I'm going to paraphrase what I just heard you say. So you gave me an example. You gave me an example of 4, what'd you tell me, 4N?
Yeah, the first one, 4N plus 10N.
And 10N? Oh, you're looking at the examples on your paper. Okay, cool. And so those are like terms, a 4N and a 10N. So that's an example. Now tell me what the definition is, because you're right, that is an example. So what the heck is a like term then? We got a really good example that's going to help us later because it came from our paper. But what is a like term? Amy? Ooh, a same variable. I like that she used that word variable. Because earlier somebody called it a letter. They're not wrong, but we want to be a little more mathematical. Same variable. They also have to have the same exponent. This is the part we always forget. I'm going to show you what I mean by exponent in a second. Same variable and the same exponent. So Jaden gave us an example already of 4N and 10N. I'm going to give you another example of like terms. 10x squared and negative 3x squared. Not only are they the same variable, but they also have the same exponent. Yes, sir?
So don't you times the 10 by 2?
We don't. I'm going to show you what we do with them in just a second, sir. Right now, just as long as we know what they are. I'm going to give you one more example of like terms. Any numbers are like terms. You can always put numbers together, okay? 3 and 5, they're the same. I know the definition says same variable, same exponent. Well, the fact that those don't have a variable, that also means that they're like terms. So the same way that having the same variable makes it like terms, the fact that they don't have a variable at all makes them like terms as well. You can always put those together. Which brings us to the term combining like terms. When we are combining, what's the word combine mean? What are you doing when you're combining something? You're just putting it together. So we're putting together the like terms. So I'm going to give you an example that's very similar to one that came from your paper you're getting ready to do. 3x minus 7x. I want to combine those two terms. I know that they're like terms. How again do I know that they're like terms? I don't want anybody to yell at me because I'm going to pick somebody randomly in a second. I'm going to pick a table in a second. So be thinking, how do you know you can combine them based on the definition that we just wrote? How do you know that you can put them together? Hey, somebody at table 3, please tell me, how do I know I can put those together? They got the same variable. Does it matter that one's a plus and one's a minus? Doesn't matter. Sometimes people get confused and think, oh, but they're not both positive, so that means they're not like terms. That makes no difference. It's all about the variable. You're right, ma'am. So if I'm going to put those together, the reason we worked on all those negatives for the last few days is because this is where you're going to have to apply them. So if I've got positive 3 and I'm combining it, remember, subtraction and negative really means the same thing. So I'm a visual learner. I really like to visualize things. So this really means that I've got 3 positive x's, and then I've got 7 negative x's, right? So I got 3 positives, I got 7 negatives. What's going to happen when those positive, you don't have to draw the picture if it doesn't help you. I'm visual, so it kind of helps me a little bit. When I combine those positive 3x's with 3 of those negative x's, what's going to happen to them? Somebody from table 7, please tell me. What's going to happen to them? Why am I going to end up with a -4? You're correct. Tell me why. What happened to all those ones I just circled in blue? They're gone. They canceled each other out. So yes, ma'am. So if I combine positive 3 x's with 7 negative x's, I get 4 negative x's. Hopefully this is coming back to us a little bit. You can only combine them if they have the same variable, the same exponent. I'm going to give you one a little more complicated now. Something very similar to the paper you're going to be doing. Now, there is absolutely no shame if you end up getting this incorrect. I haven't really taught you how to do this yet. And some of us didn't have the best middle school experiences. I understand that. I totally get it. But what I do want you to do is not just sit there and write nothing. If you don't feel comfortable writing the answer on your paper yet, get a dry erase board. Those mistakes go away real quick, right? That's the point. That's why we keep them around. If you're not 100% sure, or even if you just want to write on the board, I don't care about that either. That's just where you prefer to write. I want you to write down this problem, and I want you to at least take a guess. I'm going to give you a minute to think. I want you to talk to somebody next to you. Y'all decide what you think is a good guess. And don't you dare not write down nothing. Put something. I know this suspense is killing you. All right. Let me get you back up here, please. I love all these good conversations I hear. So let's see if we can get to the right answer together. Now, if you get ready to tell me a mistake, there ain't no shame in it. I haven't shown you how to do this yet. We're all just taking educated guesses right now. Okay? Who wants to tell me their guess? Because that's what this is. It's just a matter of guessing. Jordan, and we'll go to table 6 next.
-9 plus 6p.
What?
-9 plus 6p.
-9 plus 6p. So remember, these are all just guesses. I'm not saying what's right or wrong yet. So why guesses that we don't know if they're right yet, I'm going to put them in blue so that you guys can tell. Now, why do you think that that's correct?
Who, me?
Mm-hmm. Yep, why do you think that's right?
I added the 5p and the p, and it gave me 6p, and then I had 1, and then took away 10 from 1.
So you added, correct me if I'm wrong, you added the 5p you just told me, and you added the 6p, right?
No, the p, and then I got 6p.
That's what I meant. I'm sorry. You added the 5p and the p. My Kia was doing something very smart that her teacher showed her a little bit ago, where she puts something underneath the stuff that she can combine. She put one line underneath the terms that go together, and then she put 2 lines underneath the other ones that go together. I do this kind of the same thing, but I like to use color is the difference between that. So what he said so far, Jordan said he combined -5p and p and got 6p. And then he said he combined 1 and -10 and got a -6. I'm wondering, sir, if you can please tell me why you ended up with a -9. I see you, ma'am. I'll get you in 1 second. How'd you get a -9? How come you didn't add the 1 and the -10 together?
Because I took the 10 away from the 1.
Why'd you take 1 away from the 10?
It's a -10.
Because it's a negative, and that one's a positive, right? I agree with Jordan. That part is correct. Ding, ding, ding. We got a winner about the -9. Because that's a +1 that I'm adding to a -10. That's going to give me a -9. Ma'am, what would you like to add to this?
If you draw it, you would have to take away the part because the p don't equal 1.
All right, so I'm buying what you're selling. So you're telling me that right there means you have 1 p? Yes, ma'am, I agree. So you just told me to draw a p? And then what else should I do?
Negative p, so 5 negative.
And 5 negative p's. Okay, so what she's telling me to do right now is draw 5 negative p's. And then 1 positive p. I agree with you about that, ma'am. You're right. I love that strategy that you just used. What happens if I draw it out? What's going to happen now that I've drawn it out?
You can take away the positive P.
A positive P and a negative P is going to cancel each other out. What am I going to be left with, Annie? A negative 4P. So Jordan, he got us there. He got us almost to the finish line. What is the tiny adjustment that we need to make? The negative 9, don't change that. The negative 9 is spot on. We're leaving that be. What do we need to fix? What should that 6 become? A negative 4P. Okay, so I'm gonna make a little adjustment, and that's gonna be a minus 4P. Because if we combine negative 5P with a positive 5P, the way my Kia just suggested we draw it out, now it's real easy for us to see, isn't it? If that's what you gotta do to get the right answer, I couldn't care less, guys, draw it out. There's a reason that we have like boards and stuff around all the time, because I encourage you to do those things and it helps you to make sense of the problem. So now that we've done one very similar, I'm going to give you another one now that we've talked that one through as a group. I want you to try this one. I'm going to give you a minute. If you want to try it just on your own, you can try it independently, but it sure can't hurt you to ask somebody around you too. Double check yourself. All right, who's going to help me out? Okay, Amy, what you got for me? Destiny, I'm going to let you add in a second. We're going to do a part way. Okay, so Amy, help me get started. First of all, what are the like terms? What am I going to combine? 5x and negative 2x. So Destiny, when I combine 5x and negative 2x, what am I going to get? I'm going to get 3 x's. Now, Amy, what are the other? Am I going to combine anything else? Negative 3 and 6. Who's going to tell me what I get when I combine a negative 3 and a 6? Okay, yes, she's telling me. I knew you knew it too. Is it a positive or a negative 3? Why is it a positive 3? Because you got more you're combining a negative with a positive, and you got more positives. Yes. 3x plus 3.
That's all a lot of right answers.
I know. Yay. So this is all coming back to us from middle school now. Hey, I think we got the like terms part. So I'm going to move on to the other part for you because I'm going to show you something new. No, I'm not doing another one of these. You're right. You got it. We're not doing another like terms. We are, however, going to make sure we remember what distributive property is.
Please keep my dress out.
What'd you say, baby?
Please excuse my dear Aunt Sally.
Oh, now you're thinking of what we're going to do tomorrow. Tomorrow we are going to talk about Aunt Sally, but not today. Okay? Now, distributive property is one of those things that it's easier to give you an example than it is to give you a definition. Or maybe I'm just a bad teacher and I just never figured out a way to give a good definition. I don't know. But the only way I can get kids to understand it for the most part is by showing you what to do. Here's what I want you to do, just like that last one where we were combining like terms. I'm going to give you an example problem. You decide on your own if you're going to do it on the paper, if you're going to do it on a board. I want you to at least try to take an educated guess before I tell you what to do. We're going to do this problem right here. We're going to use something called the distributive property. I haven't told you what it is yet, so there's no shame if you don't get this right. Who knows? But I know there's some background knowledge in there somewhere. Whether it was 6th grade or 7th or 8th or all three, somebody showed this to you before. Now, they might not have done a very good job of showing it to you. Or maybe you weren't listening, but you've seen it. So I want you to check with a partner for a minute. Take a guess. That's perfect because it's not due till 3:30. Okay, who's got a good guess? Who wants to tell me their good guess? Somebody that I haven't heard of. I've heard from too many of you all today. Y'all are old news. Go away. Yes, ma'am. What we got? We're just go ahead and tell me what you think it is, and more importantly, tell me why you think it is.
I think it's 3x plus 6.
Why do you think it's 3x plus 6?
So I did put the 3 into the x and then the 3 into the 2 and then I got that.
So you put the 3 with the x, and then you put the 3 with the 2. Why'd you do 3 times 2? I don't see no multiplication symbol anywhere.
Because that's how I was taught.
Okay. I don't see a multiplication symbol anywhere. Oh, what? Oh, yay. Okay, if you don't know this, write this down. When a number is sitting next to the parentheses, I know those are kind of ugly parentheses. When the number is sitting next to the parentheses, so I'm talking right there. See that 3 sitting there? There's nothing in between it. No adding, no subtracting, no nothing. That implies multiplication. So when a number is sitting next to the parentheses, that means multiply. So, ma'am, you are totally right. That is exactly, I saw a lot of right people without me having to tell you. Okay, so that implies multiplication. So I'm going to put the problem back down here for a second. So 3x plus 2. So that's why it's called distributive property. You are taking that number on the outside and you're distributing it. You're giving it to all of the people inside of the parentheses. So you need to multiply the outside number by everything inside the parentheses. Well, I didn't say that right. Shut up. So you're going to take that outside number and you are going to multiply it by everything inside of the parentheses, and I do mean everything. So that means I'm going to take 3 times x, and then I'm going to do 3 times 2. So 3 times x is simply 3x, plus 3 times 2 is 6. Now let me ask you one question though, ma'am. When you or either one of you two, since you both told me you got 3x plus 6, how come you didn't put it together to get a 9x? It's not combining like terms. That's what you were getting ready to tell me too, wasn't it? X and a 6, you can't combine an X and a 6. That's why it's as simple as it's going to get. You're done. If you had like terms, you'd be able to put them together, but you cannot. I'm going to give you guys one more. And then I'm going to let you guys just practice on your own or with a partner because you guys are, I think you're not going to really need me. But I'm going to give you a tricky one because I'm going to throw some negatives in there.
She said, obviously you are.
I'm going to give you a minute. Okay, who's feeling really confident in their answer? Or even if you're not confident, who cares? Who's got, Mikey, what do you think? What do you think?
I did negative 3x plus 24.
Negative 3x plus 24. Will you please tell me where you got that from, ma'am?
Because negative 3 times x is negative 3. And then a negative times negative is a positive. And 3 times 8 is 24.
What I love is that she remembered her integer rules. A lot of people would have done this. Remember when I write it in red, how it's incorrect? Okay. A lot of people would have done that because they forgot that's a negative 3. And remember, minus and subtraction means the same thing. So that's really a negative 3 times a negative 8, which is why it's a plus 24 in your answer, not a negative 24. If I had $1 for every kid that says a negative times a negative is a negative, it's a very common mistake, nothing to be ashamed of, but we want to avoid it if we can, obviously. Okay, I don't think you guys need any more from me.